Hi everyone, morning. Hope you all are doing well. Exciting news. You only have a couple more weeks of distance learning until what they're calling summer break. Not quite the normal summer break, but at least you only have a couple more weeks to get through of this weird school situation. So we are continuing on with transformations. This is our last transformation. It is called a dilation. And essentially what it means is that we're either blowing up a figure, meaning we're making it larger on the coordinate plane, or we are shrinking it, meaning we're making it smaller on the coordinate plane. So when we take a look at this, I'm just going to go over example 1 with you. This is page 488. A triangle has vertices of 0, 0, 8, 0, and 3, -2. Find the coordinates of the triangle after a dilation with a scale factor of 4. So the main thing we need to point out is that we have a scale factor of 4. That means that we are increasing the size of this by 4. So I take my first ordered pair, which was 0, 0, and I multiply each value, so the x and the y, each by 4. That stays 0, 0, because anything times 0, 0. Then I take my next one, which is 8, 0. I do 4 times 8, which made the 32, and then the 0 stays. And then 3, -2, multiply those both, and I get my new ordered pair. Then I go ahead and I plot this new image, and I need to make sure to show that it's the prime image. So I'm using that like apostrophe notation in the corner, and there I have it. I've just increased the size of this triangle by 4 times. So here's another example. A figure has vertices of, let's see, make sure you guys can see all the way. A figure has vertices of -2, 4, 1, 4, 3, -1, and -3, -1. Find the coordinates of the figure after a dilation with a scale factor of 2. That means that this is growing by 2. So my W, which was originally -2, 4, I'm going to multiply this by 2. And my new W here has to be -4, 8. So there I go. I have my X here. I have 1. I'm going to scoot this up a little bit. Hopefully you can still see. I can never tell what's going on here. 1, 4. I multiply that by 2. My new X here is going to be 2, 8. I do the same thing here with my Y. Of course, I've run out of room because I'm working inside a milk crate, so it's funky. Y was 3, -1. I multiply that by 2. My new Y becomes 6, -2. That's my Y. And then my last one here, which is my Z, I'll write it up here. Z is -3, -1. Multiplying those both by 2, my new Z becomes -6, -2. There we go. So those are going to be my new points. I'm going to graph them. If I was graphing them on the coordinate plane, make sure to prime so I show what is the original image versus the new image. And there you have it. Really, it is that simple. So looking at this next one with you all. Okay, there we go. So looking at this next one with you all, just going over number 2, a figure has the vertices listed. Graph the figure with the dilation with a scale factor of 1/2. So if I have a scale factor of 1/2, that means that I'm taking the original ordered pair and I'm multiplying each X and Y by 1/2. So that means that I would be taking my figure and I would be shrinking it. So we're going to go ahead and we are going to do B together. So I have these vertices, negative 1, 1. This is my F. I have 1, 1. This is my G. I have 2, negative 1. This is my H. And I have, I'm going to say that's I. And that is negative 1, negative 1. This is I. So I go ahead and I can plot these here. I have something that looks like that. Okay, now it says I have a scale factor of 3. So that means I'm going to increase this by 3. I'm going to make it 3 times larger. So if I have F, which is negative 1, 1, and I multiply that by 3, my primed F, my new F, is going to be negative 3, 3. So 1, 2, 3, 1, 2, 3. This is where my F1 is. Then I have G, which was 1, 1, multiply that by 3. My primed G is 3, 3. So this is 1, 2, 3, 1, 2, 3. This is where my new G is. Then I'm going to go ahead and do the same for H, which was 2, negative 1, multiplied by 3. My new H is going to be 6, negative 3. So 1, 2, 3, 4, 5, 6. I lost count, but I think this is right. 1, 2, 3. This is where my new H is. And then my I, which was negative 1, negative 1, multiplied by 3. My new I here is going to be negative 3, negative 3. So 1, 2, 3, 1, 2, 3. This right here is my new I. Then I go ahead and if I was not doing this in my room and I had the proper tools, I would be using a straight edge here. You should be using a straight edge for sure. I just don't have one handy right now. Okay, so there we go. That basically is it. You guys know how to multiply, you know how to plot points, you know how to increase or decrease, so you should be good to go. Last thing that I will discuss, provided you can see this, is right here. This is just another example. So through a microscope, the image of a grain of sand with a 2500th millimeter diameter appears to have a diameter of 11 and 2500th millimeters. What is the scale factor of the dilation? So write a ratio comparing the diameters of the two images. So remember that a ratio is just a comparison between the two. So I would take the diameter in the dilation, which is here, and I would take the diameter of the original. So I come up with this fraction here. That's our comparison. I want to also point out that a fraction bar means division. So due to the fact that the numerator is larger than the denominator, I'm going to go ahead and divide here. That is how I came up with the scale factor of 45, because 11.25 divided by 0.25 came out to be 45. And that is that. You guys have the skills for this. You might just have to think back to the stuff we learned in the beginning of the year, but I know you can do it. So I hope this helps, and I will talk to you all soon. Have a great day, everybody. Miss y'all.